So chapter 2, section 5, properties from algebra. In your textbook, it starts on page 97 if you guys are actually referring to your textbook. One other thing I wanted to show you is in your textbook, what I just said. Okay, so again, these are your properties of equality. You have your addition property when you add the same number to both sides, subtraction property when you subtract, multiplication when you multiply, and then division when you divide by the same number on both sides. We will use these properties to justify our statements when writing an algebraic proof. Anybody still need the slide? Okay. Okay, these may be some new things to you. There's a few that you've probably seen before. The first one is the substitution property, and this is when you're going to substitute something for one of your variables. The reflexive property, you can think of this as like a mirrored image, a reflection. So it's going to be the same thing equals itself. Then you have the symmetric property of equality. Think of a line of symmetry. So like if I were to draw a line through here, through the word then, and then if I were to fold this up, notice the B's would match, and then the A's would match. Sort of like a line of symmetry. So the symmetric property of equality. And then you have the transitive property. So if A equals B and B equals C, then A equals C. This is sort of like your law of syllogism. Notice these two B's here are the same, just like in the law of syllogism. The conclusion of the first statement was the hypothesis of your second statement. And then distributive property, which everyone should be familiar with, is when you distribute a number outside of your parentheses to both of the terms inside. So these are some additional properties of equality. Everybody good? Anybody still need it? Okay. All right, so now here are some of the same properties we saw in the previous slide, but now they're going to be applied to angles and segments. So again, if you had two line segments, DE and DE, this is your reflexive. It's like a mirrored image. It's the same thing on both sides of the equal sign. You can also apply this to angles. You can also write it with the little angle symbol. Angle D equals angle D. Then you have your symmetric property. Remember, it's like a line of symmetry. So notice that the FG's match and then the DE's on the outside if you were to fold it up. Same thing with the angles. And then again, your transitive. These two things, the end of this one needs to match the beginning of this one. And then you can finally conclude that the original hypothesis, it matches with the conclusion of the second statement. And that's your transitive. Again, it's like the law of syllogism. We're just applying it now to segments and angles. When we get into the geometric proofs, this is what we're going to be using, some of these. We'll also go back, use our segment addition postulate, our angle addition postulate, the midpoint, the bisecting. All of these are going to be reasons for our proof, all of the postulates. Anybody still need this one? Okay, so here we go. We're going to come up with a property, and this is what you're going to have to do on the quiz. I am going to give you a statement, and you will have to tell me what property could justify or give the reason why it's congruent or equal. So for number one, what property do you see? Reflexive? No, not reflexive, but Hayden? Symmetric. This is the symmetric property of equality. Remember, we could draw like a line of symmetry here and see how the CDs match the ABs. So this is the symmetric property. Prop of equal. Okay, the next one. What property is that? Kimberly?
Distributive.
Good, distributive property. Next one. What's happening in this next picture? Okay, what happened from this to this? What changed? Oops, it didn't highlight. From here to, from this one to this one. What happened? Hayden? No, because nothing matches here. Like the 24 and the B don't match.
The substitution.
Good. I took out the B, and in place of the B is now the 4A, which is what B equaled. So this is the transitive property. I'm sorry, not transitive. Yes, sorry. This is the substitution. Thank you. I'm thinking what you said. And okay, substitution. Sorry. You replaced B with 4A. All right, and then the last one. What happened from here going to here? Hayden? No. What did we do to the 12 to make it 36? So the multiplication property of equality. So you're going to figure out what did you do to this first statement to make it turn into this. And we actually multiplied both sides by 3, which made the bottom cancel. And then 12 times 3 gave me 36. Everybody got any of these properties? You will have to do this on the quiz on Monday. All right, next one. Let's walk through this. All right, now, when you're going to usually be making a 2-column proof. So this is going to be, the first column will be your statements. And then over here, we're going to have our reasons or our justification. Now, the first step is always going to be the same. And it's going to be what's given to you. So step number 1 is going to be given. They're going to give you a problem, or they're going to give you a statement of some kind of information that's given to you. Okay, what did they do in step number 2? So this is 1, 2, 3, 4, 5. Step number 2. What changed from this one to here? What did they get rid of, or what did they move to the other side?
They multiplied the 3.
Good. They multiplied both sides by 3, so this is the multiplication property of equality. Prop of equal. Now we're going to the next. We're going to go from here to here. What did they do from step 2 to step 3? Alex? Good. They used the distributive property. Okay, now we're going from step 3 to step 4. What did they do in that step? How did they get to the 14? The addition property of equality. And lastly, what did they do from step 4 to step 5? Yes. Good. The division property of equality. So you've really been doing these all along. You've just never had to explain step by step what you're doing. Does that make sense? Okay. Anybody still need the slide? Let's go on to, and that's it. Let's see if we can make up another one. Let me find a problem we can do, just so we can get a little bit more practice. Okay, we're going to try one more example before I let you guys start your homework. Okay, again, there's more than one way to start out by solving this. We can either decide to leave the fraction alone, or we could multiply everything by 2 to get rid of it. Okay, I'm going to work through it by leaving it the fraction for right now. So again, remember your first step, or whatever the first thing is, it's always given. Step 2, what should I get rid of first? The 3. I'm going to add 3, and I'm going to just show you in red. You wouldn't show this in the proof. You would go right to what the answer is. But I'm going to show you what we're doing here, and then I'm going to write it.
Can you pretend, Nicholas? Sure. Can student posted?
Yes. Okay, so I'm using the addition property of equality from step 1 to step 2. Because I'm adding 3 to both sides. Again, you don't have to show the add 3, you just show what you would get. Okay? Now, what's going to be my next step to get x by itself? Okay, Matthew? Good. I'm going to multiply by the reciprocal, which is multiplying both sides by 2. It will cancel. And now I'm left with x equals 26. Which is the multiplication property of equality. So basically what you're doing with these algebra properties is you're going to solve an equation and justify each step in your solving process. So you do have to do it step by step. Any questions on these algebra properties? Okay, so what we're really doing when you have that fraction next to a letter, so basically at this step, you could have said division property, but you would have showed divide by 1/2. So yes, you could have done your proof that way, absolutely. All right, so right here at 1/2, x equals 13. Yes, we are dividing by 1/2, but when we divide fractions, what are we really doing? Remember, you do like a keep flip change or a stay change, whatever you were taught in middle school. So really what we're doing here is 13 divided by 1/2, which really means turn it into a multiplication problem and multiply by the reciprocal, which is 2/1. So that's why in my proof, I stated that it was multiplication property. Now, back in your proof, everybody understand what he just asked? You know, why isn't it dividing? Yes, it was, if you want to show divide by 1/2. But essentially, dividing fractions is multiplying by the reciprocal.